Okay, this is the second example of a kind of question you might see on math involving multiple regressions. Again, there's no real, not really like a story behind it. It just says given data based on GRE total scores and undergraduate GPA. Can they be used to predict graduate GPA? Okay. So we have two things that could be affecting the possibility of one outcome. So to determine the following multiple regression values, again, they're going to give us a lot of information from our readout. We don't need all of it, but it's important to know where to find it because you're going to be asked to find it on MAT130. You can use Excel, but we said in the last video that I think this website is much more straightforward. So the first thing I'm going to do is go to that Stats Blue website. We're going to click on the multiple regression calculator right here. Okay, it's going to take us to this page. And again, I've already gone through and I have input all the data. Make sure you label the data appropriately and make sure you put Y on the left column. Sometimes the columns are reordered. Just make sure your Y values are to the left and then X1 and X2. Double check to make sure everything's put correctly, and then we're going to hit calculate. Okay, we get a bunch of stuff. But now it's important just to go step by step and figure out what they're asking and then find it appropriately in the data readout. So this says report intercept and slopes for the regression equation accurate to 3 decimal places. Now it has an A here, a B1 and a B2, but on our readout we don't have an A, we have B naught, B1 and B2. So just know that when it says A here, it's actually referring to B sub 0, which is also sometimes called B naught, nautical. So that's the value they're looking for. So then we have our B naught is going to be this coefficient, or this number out front, it's constant, 1.6363. Okay. Our partial slope for X1, which is B1, is going to be negative 0.0013. And our partial slope for X2, which is B2, is going to be positive 0.6015. 6015. Okay, now it says report the sum of squares accurate to 3 decimal places. So where do we find the sum of squares for the regression and the sum of squares for the residual? Well, you're going to scroll down a little bit, and you'll see the analysis of variable table, or ANOVA table. So we have regression, residual, and total. The sum of the squares for our regression is going to be regression. The sum of squares column meet, that's going to be 0.3962. And the residual, the sum of the squares of the residual, is right below it, which is going to be 0.2726. Okay, and then it says test the significance of the overall regression model. So when we do that, that's the S test for overall significance. So our null hypothesis, whenever we do that, is going to be all of our coefficients, the coefficients for each variable, in this case B1 or beta 1 and B2, however many there are all going to be 0. That's our null hypothesis. The alternative is going to be that at least 1 is not 0. So we'll say at least 1 of those betas does not equal 0. Okay, so now we need that information. We need the overall F ratio statistic, the test statistic, and the p-value. So I'm going to go back to that. The overall fit, the summary of overall fit has everything we need. So the overall F statistic is 3.6337. And the p-value associated with that statistic is 0.1061. Okay. It says report the variance of the residuals accurate to 3 decimal places. We'll go back to this. The variance of the residuals, which they've labeled for us MS-RES, or the means of the squares of the residuals. It's going to be where this MS and the residual error interact, where they meet up. So it's going to be 0.0545. So then it says report the standard error of the partial slope estimate for the GRE total along with the test statistic accurate to 3 decimal places. So it's looking for the standard error associated with one of our coefficients. Okay? So we report the standard error of the partial slope estimate. So if we go back to our data, it's the error associated with the first coefficient, which is the coefficient of our x1. So if you look up this top box, x1 standard error coincide right here, 0.0071. So 3 decimal places will be 0.007. And the t-value associated with that same coefficient, the t statistic, is going to be right here, negative 0.1914. Okay, it doesn't ask us to make any claims about the data. It just wants all of this information laid out. In other questions, it might ask you to conclude something based on your p-value or based on the p-value of individual coefficients, but not for this particular